Hello students, welcome to Lab D1. This lab begins on page 75, and we're simply going to be putting 3 capacitors in series. So that's what we're going to look at. Here's my circuit here, and you can tell that basically I have these resistors, C1, C2, and C3. I know in the laboratory it talks about specific characteristics, physical characteristics of the capacitors, but capacitors come in all shapes and sizes and different colors. So you'll just need to make sure you look at the notation from the manufacturer, and then you're going to use your digital multimeter if it has a farad meter, or you'll use a separate LCR meter to measure the actual capacitance those particular capacitors, so you can assure that those are correct. So we're going to build this circuit, and I've got this set for this particular lab has this thing set, I think, for 6 volts at 60 hertz. So if that changes, your instructor will let you know, but that's what we've talked about on this. So that's what we're going to do on this particular laboratory. Now, the one thing that we want to do on these laboratories is we need to calculate what the opposition to current would be, and that's what we call our reactance. When I'm working with calculating what we call X of C, or capacitive reactance, the capacitive reactance, the formula we use is 1 over 2 pi F of C. F being frequency and C being the value of the capacitor, and that's what I've done here on these particular equations. As you look here, you can tell that my X of C is equal to 1 over 2 pi times 60 hertz times 0.33 microfarads for X of C1, your capacitive reactance. Your capacitive reactance for capacitor 2 is 1 over 2 pi times 60 hertz times 0.47 microfarads. And then finally, when we're looking at this very last one, is that we're going to look at 2 times pi times 60 hertz times 1 microfarad. So if you go ahead and do the math on that, you should be able to figure out what your X of C is. And then experimentally, what we're going to do is we're going to build this circuit, and this circuit has 3 capacitors in series, and that's what I have here. They're just in a straight row. Over on this end is attached to one end of my function generator, or my trainer, and this other end is attached to the other end of the circuit. So you're going to set that up for the correct voltage, and then you're going to take your voltage readings and record that on the table that happens to be, I think, on page 76. So once we do that and we built our series circuit, we're going to do some computations here. I do want you to remember that when we are dealing with capacitors in series, we are going to use the reciprocal formula. So the total capacitance is the reciprocal of the reciprocals, as I like to call it. So 1 over C1 plus 1 over C2 plus 1 over C3. If I take the reciprocal of those 3's added up, then that should give me, so I've just replaced those symbols with the actual numeric values. So you're going to do that with your calculator and get the computations out. Now, what are you doing as an experimenter, as a learning technician? What are you doing? Well, I've asked you to measure these 4 things in this experiment. You're supposed to measure the voltage on the capacitor 1, voltage on capacitor 2 and 3, and then you're going to measure total current. So those are my voltage drops and my total current, which in a series circuit there's only one current. Then I actually can use Ohm's law to calculate what my total impedance is. This is what this Ohm's total is. I take my total applied voltage, in this case 6 volts, and then I take the actual measured value I did experimentally. When I have those 2 values, those 2 known, I can calculate the unknown, in this case ZT, and you're just using Ohm's law. Those are actual observations you make, and you can understand what you were doing there. Now, once you do that, is you want to continue with the lab and answer the questions that go along with the lab. If you have any questions or need any help on identifying your capacitors or measurements, your lab instructor is there to help you. Take care, and I hope to see you in lab.